Hello everybody. Welcome to this series of 4 short programs on the geological evolution of Mauritius. The first program deals with Earth, our dynamic planet. In the second program, we are going to look at the different volcanic episodes in the building up of Mauritius. The third program will be entirely devoted to our volcanoes, and we are going to look very closely at some of the volcanoes of Mauritius. And finally, the fourth program will be on the valuable geological heritage of Mauritius. Planet Earth is a very unstable planet. Every time we hear of volcanoes, we hear of earthquakes of high magnitude which cause a lot of damage and loss of life. We will never forget the giant earthquake of Indonesia of 26 December 2004, which triggered devastating tsunami and caused the death of more than 300,000 people, and also did a lot of material damage to the region. Why are there volcanoes and earthquakes of different magnitude in certain specific areas on the surface of the globe? Well, this is because there is a lot of movement on the surface of the Earth. And what is important, there is a lot of movement deep below Earth. Planet Earth is a dynamic planet indeed. Do not forget that planet Earth rotates on itself. This is what we call rotation, and that it also moves around the sun, which we call revolution. Why then there are volcanoes and earthquakes concentrated in specific regions around the world? Let us make a tour of the world to see where volcanoes are located. This is a world map, and all the red shade shows location of volcanoes. As you can see here, most of the volcanoes are located near the sea. In other words, along the margin of continents. This is what we call the Pacific Ring of Fire. Just imagine, along the Andes we have more than 1,000 volcanoes, and it is also good to know that there are about 600 active volcanoes around the world. We have volcanoes also in arcs along island. This is Indonesia. We have volcanoes in the sea. This is the mid-Atlantic, and there are no volcanoes in the center of continents. For example, in North America, no volcano in the center of South America, no volcano in the center of Australia, and no volcano in the center of Asia, with the exception, of course, of Africa, where there are volcanoes along rift valleys. Let us now have a look at a map of the world to see where there are earthquakes. Here you are, location of earthquakes. You can see there is a parallel between location of volcanoes and location of earthquakes. Again, volcanoes are located along the margin of continents, in the sea, along island arcs. Again, I mentioned Indonesia. This is the mid-Indian Ocean ridge. What is dangerous when earthquakes are located along the margin of continents is that there are many towns and many cities, and this causes a lot of death. Again, this is the Pacific Ring of Fire, where there are notorious and violent earthquakes of high magnitude. Again, this is the Indonesian island arc, and this is Japan. Do not forget that we also have a lot of earthquakes in the sea. This is a very nice picture of the Pacific Ocean. Here again you can see the margin of plates. We will come to plates later on. Look at the number of volcanic mounts in the Pacific Ocean. In fact, there are more than 50,000 volcanoes here in the Pacific Ocean, and this is the island chains of Hawaii. Here we have Japan. Therefore, this is where we have dangerous earthquakes and also a lot of volcanoes. Therefore, we conclude that volcanoes and earthquakes coexist. As I have just said, planet Earth is a very unstable planet. Since some 200 million years ago, our continents, our oceans, and our islands are all moving. Yes, they are all moving at different speed, ranging from 4 centimeters to 7 centimeters a year, and moving in different directions. This means that there are forces that are making our big land masses and ocean move. And as they move, they form high mountain ranges and cause volcanoes and earthquakes. Let's have a look at what is happening deep below the Earth's surface. Deep inside the Earth, it is very, very hot. Every 1 kilometer depth, temperature rises by 30 degrees Celsius. Deep below, therefore, the temperature may exceed 2000 degrees centigrade. It is so hot that the rocks melt. They look like hot coal tar. They are called magma. What makes our Earth dynamic is that deep inside it is very, very hot. So hot that nothing remains static. This is why there are convection currents deep inside the Earth, and these convection currents break land masses and ocean and make our continents and ocean move. It is also important to note that the surface of the Earth is subdivided into several large and minor plates. They are called lithospheric plates. The plates are about 100 kilometers in thickness. They are light and they float on the molten materials deep below the Earth. Continents, oceans, and islands lie on the plates. This is important to remember, that plates carry our continents, our oceans, and our islands. Therefore, as they move, continents and ocean also move. On this world map, you are going to see the different lithospheric plates. Now, what is important here is that plates move in different directions. You have plates moving towards each other. They are called convergent plates, and plates moving away from each other, they are called divergent plates. Along continental margins and in the ocean, where plates move towards each other, this is very dangerous because they trigger violent earthquakes. Whereas where plates move away from each other, they do not trigger violent earthquakes, and this is why I say that since Mauritius is located very far from the mid-Indian Ocean ridge, we do not have risks of having major earthquakes in Mauritius. There are a few volcanoes which are located not along the margin of plates, but deep inside continents and inside oceans. They are known as intraplate volcanoes. Let us look at their distribution on a world map. As you can see here, the red spots show intraplate volcanoes. It means that they are located far from plate margins. You can see Rainier Island here. You can see the island of Hawaii. In fact, the whole island chains of Hawaii are located deep inside plate margins. These are called hotspot volcanoes. This diagram helps us to understand how a hotspot volcano is formed. This is the hotspot which remains static, so it pierces the plate and emerges as a volcano. Lithospheric plates, as I mentioned, move, whereas a hotspot is static. It remains on the spot. So as the hot plume pierces the lithospheric plate, the magma emerges to form an island. So the hotspot remains static, the lithospheric plate moves, and a chain of islands is formed, as you can see in this diagram. This is how the islands of Hawaii has been formed. This diagram explains the origin of the islands of Hawaii as hotspot volcanoes. What we see in this diagram, the Pacific plate is moving in this direction towards the northwest, and then there is the presence of a hotspot. Remember, a hotspot is static, whereas a plate moves. This means that the island of Kaula, about 11.3 million years ago, was here. So as the plate moved, other islands popped up from this hotspot. Here you have the island of Maui, where we have a dormant volcano called Haleakala, and this is mainland Hawaii. Here we have active volcanoes, the volcano of Mauna Loa, Mauna Kea, and Kiloa. Hawaii is therefore a classic example of hotspot volcanoes. This is a map of the Indian Ocean area. Here we can see a series of plates. You have the India plate, the Australian Indian plate, the African plate, and minor plates like Burma plate and Somali plate. Do not forget that the Mascarene Islands are located on the Somali plate, and that the Somali plate is moving in this direction. As I mentioned earlier, here this is a plate margin. It is a divergent plate margin, and therefore, Rainier being a hotspot, we are all far away from a plate margin. Therefore, the risk of earthquakes in the region of Mauritius is quite low. On the contrary, look at this. This is Indonesia, and here two plates are moving towards each other. They are converging towards each other, and this is a dangerous zone for earthquakes. In fact, it is from here that the famous December 26, 2004 earthquake happened, which triggered tsunami, and the tsunami affected the whole of the Indian Ocean area. We now come to our region, the Mascarene Islands. This diagram illustrates the emergence of the Mascarene Islands. As you can see here, Rainier Island, Mauritius, and Rodrigues are not connected. They are not interconnected from the geophysical point of view. All the three islands are located on their own pedestal, on their own platform. Mauritius came out first, between 10 to 8 million years before present. This was followed by Réunion Island around 3.5 million years before present, and of course Rodrigues between 2.5 to 1.5 million years before present. This is a satellite image of Réunion Island. What we see here is the first volcano, Piton des Neiges. In fact, Piton des Neiges, at an altitude of 3,069 meters, is the highest volcano of the Indian Ocean area. And then we see the active volcano, Piton de la Founaise. And here you have the hotspot. It means that about 40 to 50,000 years ago, Piton des Neiges was here. So as the Somali plate moved towards the west, west-northwest, there has been a migration of magma on a north 120 degrees line towards La Founaise. Therefore, La Founaise being active, how long it will be active? It depends on the speed of the displacement of Réunion Island, which is carried by the Somali plate. What I can tell you is that a small island will pop up between Réunion and Mauritius. In this program, we have been looking at dynamic planet Earth. That dynamism which has triggered and which is still triggering earthquakes and volcanoes. We have also been looking at the location of these earthquakes and volcanoes, and also on the evolution of hotspot volcanoes with Hawaii and Réunion Island as examples. How interesting! Well, in the next program, we will see how Mauritius was formed. And until next time, it's goodbye from me.